Hello and welcome. In today's session, we are going to talk about time, speed, and distance. Although the concepts in this chapter are fairly easy to understand and are quite basic, the exam setters use these simple concepts to come up with convoluted problems, and given the paucity of time, it's very important to practice these simple concepts across a variety of problems. Things like relative motion, circular motion, problems based on trains, boats, clocks, races, etc., so that at the exam time you do not get confused. This is the background, and this is our key equation. Speed into time is equal to distance. Now this is the basic equation that is used across the variety of problems that you get in time, speed, and distance, and we'll take a look at a few examples in this video to see how you apply this equation. Okay, looking at the first example, this is the most basic example that you'll probably get, if you get it at all, at the beginning of your test. So here we have a body travels half the journey at 20 kilometers per hour and the other half at 30. Find the average speed. Note the keyword average. So intuitively, when you look at this, you think 20, 30, half the distance at 20, half at 30. So the average speed is probably going to be 25. Well, this is what the exam setters are hoping you would come to this conclusion. Unfortunately, the answer is wrong, because what you see is the body travels half the journey at 20 kilometers per hour and the other half at 30 kilometers per hour, which basically means that since 20 is the slower speed, it spends more time traveling at 20 and less time traveling at 30 because the distance is the same. So the average should ideally be skewed more towards 20 than towards 30, which means that the average should be less than 25. So we know that the speed, the formula that we saw earlier, speed equals distance by time, and the average speed is equal to total distance by total time. So in this problem, what we need to find out is what is the total distance and what is the total time. So let the total distance be 2d. So as the problem says, it travels half the journey at 20 and half at 30. So let's assume it travels a distance d at 20 kilometers and the equal distance d at 30 kilometers. So the total distance becomes d and d, and now we need to find the total time, which is the slightly more tricky part, at least at this level. So let's first find out how much time does it spend at 20 kilometers per hour. So you know, speed equal to distance by time, therefore time equal to distance by speed. In this case, we've assumed the distance to be d and our speed is 20. So let me just mark 20 here. So this is the time it takes to travel when it's traveling at 20 miles an hour. So this is the time you get. And now when it travels at 30 miles an hour, you have t30 equals to distance is again d. This was our original assumption, and the speed is 30. So the time taken when it travels at 30 miles an hour is d by 30. So the total time is the sum of this and this. So if you substitute that into our equation, you get d by 20 plus d by 30. So that's my equation for the average speed. Now this is equal to d cancels out, so what I essentially get is 2 divided by 30 plus 20 over 20 into 30, which essentially is me simplifying this bit of the equation, and this is basically equals to 2 divided by 5 by 60, which essentially is equal to 24. So my average speed is 24 and not 25, which is the basic arithmetic average of 20 and 30. And the reason it is 24, more skewed towards the slower speed, is because the time taken at the slower speed is more, since the distance covered is the same. So as you can see how this equation is solved, the time taken d by 20 is more than d by 30, so the final answer is skewed more towards 20, and the final answer is 24. Now this may seem like a simple concept, but advanced formats and complex scenarios based around this concept is what the test takers ask, especially at the higher difficulty level. The next interesting concept in this chapter is the concept of relative speed, which is basically the speed of one object with reference to the other object when either both are moving, or only one is moving, or they're both moving in the same direction or opposite direction, and so on. So let's take the first case where the two objects move in the same direction at different speeds, a and b. In that case, their relative speed is a minus b. Taking a quick example to consolidate the concept, let's assume two cyclists start from a point and move in the same direction at speed of 6 miles an hour and 8 miles an hour. After how much time will the fastest cyclist be 3 miles ahead of the slower one? So let's assume this is the starting point and this is A, and we have this as B. Now after 1 hour, A would be 6 miles away from the starting point, so let's say this is the 1 hour stamp. So A would have covered 6 miles and B would have covered 8 miles. So you see the difference between A and B is 2 miles after 1 hour, and that is simply because their relative speed is A minus B, which is 6 minus, or rather 8 minus 6. So the relative speed is 8 minus 6, which is equal to 2 kilometers per hour, and hence after 1 hour, if the speed is 2 kilometers per hour, after 1 hour you expect the distance to be covered would be 2. And so the question is asking in how much time will the distance between them be 3 miles. So that would simply be, if you cover a distance of 2 kilometers in 1 hour, you will cover a distance of 3 kilometers in 1.5 hours. So time equals distance, which is 3, and speed, here we're talking about relative speed, 3 by 2, so this is simply 1.5 hours. just a simple example to consolidate the concept of relative speed. Let us look at the final concept of acceleration. Acceleration is essentially defined as the rate of change of speed. Acceleration can be positive when the speed is increasing or negative when the speed is decreasing, and the unit of acceleration is speed per unit time square. If you have to find the final speed of a body that is accelerating, this is the formula. Final speed is initial speed plus acceleration into time. So these essentially covers the main concepts involved in time, speed and distance. And now let us look at more realistic problems that you might encounter in the actual test. Okay, here is the first example. Water flows into a cylindrical beaker at a constant rate. The base area is 24 centimeters square and the water level rises by 10 centimeter every second. How quickly will the water level rise in a beaker with a base area of 30 centimeter square? So essentially, let's try to portray this as a diagram. So here I have a beaker which is filled with water, and the water is coming in at a specific fixed constant rate, and say the water level goes from one point to the other, which is 10 centimeter every second. So what is the volume of water that is being pumped by whatever means it's coming in? So that would be 10 into the area of the base. So this is the base at the bottom, and that is given to be 24 centimeter square. So the water level is rising by 10 centimeters and the base area is 24. So the volume of water coming in every second is 10 into 24, which is 240. And what is the unit of volume? It's centimeter cube. So this is the area, unit being centimeter square, and this is the height or the depth or the length depending on the situation, unit being centimeter. So when you multiply centimeter square with centimeter, the unit you get is centimeter cube. The reason units are important is these prevent you from making silly errors when complicated situations are set. So going back to the problem, the water that is coming in is 240 centimeter cube per second. Now it says how quickly will the water level rise in a different beaker with a larger base area of 30 centimeters square. So in this case, let the water level rise by say x centimeters. So x into 30 is equal to the volume that we had, 240. Because the volume coming in remains constant, the base area increases, so it's likely that it will rise less than before, so less than 10 centimeters. So now we simply have x into 30 is equal to 240, which basically means x is 240 by 30, which is 8 centimeters. So that's your answer, and this is the official formal solution, and it says you are advised to use dimensional analysis like centimeter square, centimeter cube to understand what to multiply and what to divide so that there are no silly errors. The next example is a good one if you want to understand everything about relative speeds, the kind tested on the exam. So let's take a quick look at this. A train crosses a man traveling in another train in the opposite direction in 8 seconds. However, the train requires 25 seconds to cross the same man if the trains are traveling in the same direction. So what happens when you travel in the same direction? The relative velocity or relative speed is the difference of the two speeds, and when you travel in the opposite direction, the relative speed is the sum. Now the question goes on, if the length of the first train is 200 meters and that of the train in which the man is sitting is 160 meters, find the speed of the first train. So essentially you need to find the speed. So let's try to put the data in the problem in the form of a diagram. So let's say this is my train 1, let's call it A. So this is my train A and has speed denoted by SA, and in the opposite direction is coming train B with a speed SB, and the man is sitting right here. So this denotes the man. Now the problem is saying the train crosses a man in the opposite direction in 8 seconds. So the time taken by this first train A to cross this man is 8 seconds. So let me just put down the size, the length of train A, which is 200 meters, and the length of train B, which is 160 meters. So the relative speed of the two trains when they're traveling in the opposite direction is denoted by speed of the first train plus speed of the second train, and this is equal to speed is equal to distance divided by time. So let me first put the time. So how much time did it take? 8 seconds. So this is my time. And how much is the distance? Now the length of the first train is 200 and the one of the second train is 160. So is the distance going to be 200 plus 160? What do you think? Well, this actually is a bit of a trick question, and the 160 here is quite redundant. The reason is the question is saying the first train takes 8 seconds to cross the man. The man is a single point. The question is not saying that the first train takes 8 seconds to cross the whole of the second train. In the latter case, the distance would be 200 plus 160, but here we're talking about the first train crossing a man, which is a single point. So the 160 is redundant, and the equation you get is speed of A plus speed of B is equal to 200 by 8. And what else do we have here? So when they are traveling in the same direction, it takes 25 seconds. So let's put this as another equation. So when they travel in the same direction, the relative speed is the difference of the speeds of the two trains, and in this case again the distance remains 200, because here again it's the man we are talking about and not the whole train that is being passed, and the time taken is 25. So here we have two equations and two unknowns. So if you simply solve these equations, you should be able to get the speed of the first train. So let's do that quickly. 8 is 25 times and this is 8 times, and if you add these two equations, what you get is 2 times speed of A is equal to 25 plus 8, which is 33. This cancels, and hence speed of the train is equal to 33 by 2. Remember, the units here is meters per second and not kilometers per hour, and this is something you specifically need to be clear about. What units are you talking? Because you can bet on it that the exam setters would give you an answer which you'll find easy to tick, but because the units are not consistent, it won't be the correct answer. So this is the answer here in meters per second. Now let's look at the official solution. You get the two equations and you get the speed, and they convert it then into the kilometer per hour speed. Let's look at the next example. This one says John travels from A to B, which are 60 miles apart, at 11 miles per hour starting at 11 a.m. His sister leaves B from A at 1 p.m. at 8 miles an hour. When do they meet? So to do this kind of a problem, let's assume they meet at T hours after 11 a.m. So in T hours, John would have traveled 11 T miles, because speed equals distance by time. So distance equals speed into time. So speed is 11, elapsed time is T. So John would have covered 11 T miles. John's sister travels at 8 miles an hour, so she would have covered 8 into T minus 2, because she started at 1 p.m. John started at 11. So if T hours after 11 is what we're looking at, then the sister travels 8 into T by 2, since she walks only for T minus 2 hours. So the total distance that they both travel after T hours is 11T plus 8 into T minus 2, and that is equal to the total distance of 60 miles. Because when they meet at T hours past 11, they both together have covered the 60 miles distance. So here is the simple equation. So what you have is 11T plus 8T is 19T minus 8 into 2, 16 equals 60. So solving this further, you get 19T equals 60 plus 16, which is 76, hence T is 4. So the answer we get is T equals 4, which is after 4 hours of starting, that is with 11 o'clock as a reference, they meet, which means they meet at 3 p.m. So let's look at the official solution. So we get t equals 4 here, and that means they meet at 3 p.m. Moving on to our next example. This one is about circular motion. So the question is, if a motor wheel has a radius of 14 inches, how many revolutions will the wheel make in a mile? Now again, we need to be careful about the units being talked here. So here we've got a mile, which is so many feet, and the radius is in terms of inches. So the first thing to note is 1 foot is equal to 12 inches. So if you imagine a wheel here, and this is the point of the wheel where it touches the ground. Now when this wheel moves, imagine this point is embedded in the wheel. So at this stage you might see the point somewhere over here. The point has moved here. Let me just indicate the point with a cross, and then goes on and on and on, and then finally the point comes back to the ground here. So what is the distance that the wheel has moved between this stage when the point is touching the ground and this stage where the point is again touching the ground? The distance is really equal to, let me just make it clear to you. So the distance is equal to the circumference, this whole circumference of the wheel. And what is the formula for the circumference? If the radius is known, then let me just write it here. Circumference is equal to 2 pi r, where r is the radius and pi is the standard pi, 22/7. This is the circumference. Now the reason this is important is we have to find out how many revolutions the wheel makes in a mile. In one revolution, the wheel travels a distance equal to its circumference, which is this. So in how many revolutions will it cover 1 mile? So let the number we are looking for be x. So let's do some calculations here. So x into 2 pi, and substituting the radius. What's the radius? It's 14 inches. So how many feet would that make? 14 divided by 12. This is equal to 5280. And now you just simplify and you get the answer. So we have x equals 5280 into 12. You may not be able to see it here, so I'll just try to move it a bit to the side. 14 into 2, which essentially is equal to 5280 into 3 divided by, oh sorry, there was a pi here as well, 7 pi, and that is essentially this one. So quite simple. This problem illustrates how circular motion and circular speed concepts are tested on the exam. So let's look at the official answer and the solution. Here it is, similar to what we did. And coming on to the next question, Venus started walking at 3 miles per hour. Roger started from the same point 2.5 hours later and traveled at 8 miles. In how many hours did Roger overtake Venus? So this is actually quite a simple example once you get comfortable with the concepts of relative speed. So let me use this area to quickly draw a diagram to represent what's happening. So this is Venus, and she is walking at 3 miles an hour. In 2.5 hours she would have done 3 into 2.5, which is 7.5 miles. So this distance is 7.5. Now this is the point at which Roger starts, and what is the relative speed? So relative speed, they're traveling in the same direction, so speed of Roger minus speed of Venus, which is equal to 8 minus 3, which is equal to 5 miles per hour. So this is the point that Roger starts, and the question essentially is how much time will it take Roger to catch up with Venus? So given that their relative speed is 5 miles an hour, every hour Roger catches up on Venus by 5 miles. So if they start together, for example, if they start at the same point, after 1 hour, this would be Venus and this would be Roger, and the miles, this would be x and this is x plus 5. This is the concept of relative speed. Really, you can imagine Venus is stationary at this point, say. So Venus is not moving at all, and Roger is simply moving at their relative speed, so at 5 miles an hour. So this is the concept of relative speed. The relative speed of Roger with relation to Venus is 5 miles an hour, which means if you take only these two into consideration, you can assume that Venus is stationary, not moving at all, and Roger with reference to Venus is moving at 5 miles an hour, which is their relative speed. So going back to the original situation, here we have Venus who's already done 7.5 miles and Roger starts now. So let's assume Venus is stationary, not moving from here, and Roger has to cover 7.5 miles. So if his speed is 5, in how many hours will he cover 7.5 miles? So let's use our simple equation. Speed is equal to distance by time, so time is distance by speed, which is equal to 7.5 by 5, which is really 1.5. So there you go, that's the right answer. So easy enough. Hope you enjoyed it, and do not forget to leave your comments so that we can tailor our future videos for you. Thank you very much.